This is Mrs. Appia for Lesson 2 and 3 for Module 2. Student outcomes for this lesson: using the number line to model the addition of integers and understanding addition of integers. Students model integer addition on the number line by using horizontal arrows. An arrow for -2 is a horizontal arrow of length 2 pointing in the negative direction. Students recognize that the length of an arrow on the number line is the absolute value of the integer. Students add arrows, realizing that adding arrows is the same as combining numbers in the integer game. Given several arrows, students indicate the number that the arrow represents, the sum. Students understand addition of integers as putting together or counting up. For negative numbers, counting up is actually counting down. Students use arrows to show the sum of two integers, p plus q, on a number line, and to show that the sum is the distance, the absolute value q, from p to the right if q is positive, and to the left if q is negative. On page 13, our essential question is, how do you determine the length and direction of an arrow to represent an integer on a number line? Pause the video to complete exercise 1. So now let's check your answer. Our equation is 10 for the positive and -4 for the money that was spent, and the sum is 6. Real-world situations can be modeled with equations and represented on a real number line. In this exercise, positive 10 represents the $10 given as a birthday gift because it is a gain. The -4 represents the $4 spent on snacks because it is a loss. Gaining $10 and then taking away $4 will leave you with $6. Now, some people say that you could also use 10 minus 4 for this equation. This problem specifically states to use addition to write the equation, so adding a negative is the same as subtracting. And because this said to use an addition equation, we added a -4. And modeling your equation would look like this. Remember to start at 0, then model positive 10 in the positive direction, and from there, the -4, so you're going to go 4 to the left. And where you end up is the sum, which in this case is $6. Example 1. Complete the steps by finding the sum of -2 plus 3 by filling in the blanks. Model the number sentence using straight arrows called vectors on the number line. So our equation is -2 plus 3. Place the tail of the arrow on 0. We learned in a previous lesson that you always begin at 0 for addition problems. Draw the arrow 2 units to the left of 0. We're going to the left because it is a negative number. 1, 2. And we stop at -2. The direction of the arrow is to the left since you are counting down from 0. Start the next arrow at the end of the first arrow, or at -2. Draw the second arrow. The second arrow is 3 units. 3 units to the right since you are counting up from -2. 1, 2, 3. And we stop at +1. Circle the number at which the second arrow ends to indicate the ending value. Repeat the process from parts A through F for the expression 3 plus -2. So in the previous problem, the problem was -2 plus 3. And on this number line, we're going to do the problem 3 plus -2. So again, we start at 0, and we're going to go in the positive direction 3 to the right. 1, 2, 3. And from there, we're going to go to the left 2. 1, 2. And we stop at 1. What can you say about the sum of -2 plus 3 and 3 plus -2? Does order matter when adding the numbers? Why or why not? They both have a sum of 1, and order does not matter when adding because addition is commutative. Write your own story problem for -2 plus 3, and you can do that on your own and then resume the video. How does the absolute value determine the arrow length for 2? The absolute value of -2 is 2. So the arrow is 2 units long. Because -2 is negative, the arrow points to the left. How does the absolute value determine the arrow length for 3? The absolute value of 3 is 3. So the arrow is 3 units long. Because 3 is positive, the arrow points to the right. How does the absolute value help you to represent -10 on a number line? The absolute value of -10 is 10 because it is 10 units from 0. So the arrow is 10 units long. Because -10 is negative, the arrow points to the left. Please turn to page 20. In example 1, counting on to express the sum as an absolute value on a number line. Our problem is 2 plus 4 equals 6. Recall in the student outcomes that we are going to use arrows to show the sum of two integers, p plus q, on a number line. So when they're talking about p and q, p is just the first value, also called the addend, and the second value, or the second addend, is called the q value. And then the 6, the answer to your addition problem, is the sum. So in this problem, the absolute value of 2 is 2, because it is 2 spots from 0, and so you move to the right 2 places. Then your q value is a positive 4. The absolute value of 4 is 4, so you move 4 to the right, and where you end up is your sum, which is 6. And that is the model of counting up on a horizontal number line. Then let's continue down, and we'll talk about the same kind of problem on a vertical number line. So again, the p value is the first value, and you start at 0. You count up 2 units above 0, and the arrow is 2 units long and points up. So this blue arrow, this is our positive 2. Then our second value is called our q value, and the absolute value of 4 is 4. So we start at 2 and we count up 4 units. Arrow is 4 units long and it points up. And that's our red arrow here, 1, 2, 3, 4. And that models the relationship 2 plus 4 equals 6. And where you end up on your number line is the sum. And let's go over a problem on the horizontal number line, a model of counting down. So in this problem, our p value is 2, and so we are going to move 2 numbers in the positive direction. And our q value, our second addend, is a -4. Because it's negative, we're going to go to the left, and the absolute value of 4 is 4, so we're going to move 4 spaces. 1, 2, 3, 4. And that leaves us at a position of -2. So our sum is -2. Going over that same problem using our vertical number line would look like this. Our p value is 2, so we're going to move 2. Our arrow will be 2 units long, moving in the positive direction, which is going up. Then our q value is -4. We're going to move 4 spaces, but we're going to move down because it's negative. So from here we go 1, 2, 3, 4 down, and where we end up is the sum. And so our answer is -2. and negative 2 is 4 units below 2. So counting up negative 4 is the same as the opposite of counting up 4, and it also means counting down 4. Please turn back to page 16, lesson 2, and then pause the video and complete exercise 2. Correcting your work for exercise 2. So we go to the left 6, then to the right 4, and our sum is negative 2. In the second problem, we go to the right 3, and then to the left 8, and we end up at negative 5. So the sum is negative 5. In example 3, find the sum of the integers represented in the diagram below. So we notice that we're starting at 0 as we do, and we go in the positive direction 5, then we add a negative 2, and then we add a positive 3. Write an equation to express the sum, and the answer is 5 plus negative 2 plus 3. And the final position is the sum of those numbers, and the sum is 6. What 3 cards are represented in this model, and how do you know? The 3 cards are 5, negative 2, and 3. I know the 5 is positive because the vector is 5 units long and it is pointing to the right. I know that the 2 is negative because the vector is going to the left and it is 2 units long. I know that the third card is 3, and it is positive because it is pointing in the right direction and it is 3 units long. Can you make a connection between the sum of 6 and where the third arrow ends on the number line? Notice that the sum of the problem is 6 and the ending position on the number line is also 6. Would the sum change if we changed the order in which we add the numbers? For example, negative 2 plus 3 plus 5. In order to answer that question, let's check the next one. Would the diagram change, and if so, how? So let's model this problem on the number line. Our first integer is negative 2, so we start at 0 and we go 2 to the left because it is a negative number. Then our second number is 3. It's positive, so we go to the right, and it's 3 units long. 1, 2, 3. For our third integer, it's positive, so we go to the right, and it's 5 units long. 1, 2, 3, 4, 5. And the number you end up at is your sum. So would the sum change? And the answer is no, the sum does not change. In this lesson, you have learned, on a number line, arrows are used to represent integers. They show length and direction. The length of an arrow on the number line is the absolute value of the integer. Adding several arrows is the same as combining integers in the integer game. The sum of several arrows is the final position of the last arrow.